By the end of this lesson, you should be able to explain what efficiency of a device is, solve problems involving work, energy, power, and efficiency. Energy is the foundation of everything we do. All of us use energy every day for transportation, cooking, heating and cooling rooms, manufacturing, lighting, water use, and entertainment. The quality of our environment and lives will be improved when we make choices about how we use energy. One of the greatest challenges faced by our modern world is to conserve energy resources. Two motors A and B of the same power are used to push the water in two fountains. The first fountain pushes the water to a greater height than the second. Motor A is more efficient. How do we determine that the fountain A is more efficient than fountain B? What are the factors in deciding the efficiency of a system? The height to which water is raised by a fountain depends on the energy utilized by it to do work. Though the amount of electrical energy supplied to the two fountains is the same, the amount of energy utilized by it to raise the water to a height is different. Efficiency can be said as the ability to convert energy from one form to another useful form. The electric pump of the fountain converts electrical energy input into kinetic energy of the water, which is then converted to potential energy at the end. When the water is raised to a greater height, that means it possesses more potential energy. The water in fountain A is being raised to a greater height than fountain B. This implies that the energy output for the pump of fountain A is more than the energy output for the pump of fountain B. From this, we can conclude that the pump of fountain A is more efficient than the pump of fountain B. Note that in the process of energy transferred from electrical energy to kinetic energy, some energy losses happen in the form of heat and sound. Efficiency is defined as the ratio of the useful energy output to the total energy supplied, times 100%. Let's further understand about the efficiency of the motor that controls the water fountain. Use the slider to control the efficiency of the fountain to see how the efficiency affects the performance of a device. A higher efficiency means a higher percentage of the energy input is converted to useful energy. Thus, the motor can push the water to a greater height. Let's look at another example. Determine the efficiency of this fountain pump. The highest point of the fountain is 4 meters from the ground. The power of the fountain pump is 50 watts. The rate of water flow is 4 cubic meters per hour. Electrical energy input per hour equals to power input times time. The electrical energy input per hour is 180,000 joules. Mass of water lifted by the pump per hour is 4,000 kilograms. The useful energy output per hour equals to potential energy of water lifted by the pump, that is 156,800 joules. Efficiency of the pump equals useful energy output over energy input times 100% equals 87%. What happened to the other 13% of the energy input? 87% of the electrical energy is converted to potential energy of the water fountain, and 13% of the energy is lost in the form of heat and sound, which are wasted. A filament lamp converts electrical energy to light energy. The power of the filament lamp is 60 watts, and it produces 18 joules of light energy per second. What is the power lost in the process of conversion of energy? Power input equals 60 watts. Useful power output equals 18 joules per second equals 18 watts. Therefore, power lost equals power input minus useful power output equals 60 watts minus 18 watts equals 42 watts. What causes the power lost? Some of the energy supplied is used to heat up the filament, thus causes energy lost in the form of heat. What is the efficiency of the filament lamp? The efficiency of a device can also be calculated by using the formula. The efficiency of a device is defined as the useful power output against the power input times 100%. Therefore, the efficiency of the lamp is 30%. This means that 30% of the electrical energy supplied is converted to useful light energy and 70% is lost in the form of heat.
Calculate the efficiency from the values given and choose your engine. See if the car runs the furthest distance.